All right, so check this out. One of the goals that I want to try to do is one of the goals I want to try to do is get you guys ready for standardized tests and those kinds of things. So I'm going to spend the rest of the time that we have. I'm going to finish off polynomials today. That's it. And then here's what my plan is. On Friday, I want you guys to take a standardized test. You have like 4 tries, I think, and it's a 4-choice multiple choice. So you really have no reason to get anything below, like 15 out of 15 points. This one is actually in the category of like the quizzes and the exams. So these things are important. This next upcoming test that I want you to do on Friday. You need. Wait, is it not 4 attempts? Is that what you're saying? All right, let me check it right now. I'll look at it right now. The one that's coming up, you'll have 4 attempts and there's 4 choices. So literally you have no, there's 15 questions. 15 questions, 4 attempts, and there's only 4 choices. It's A, B, C, or D, and that's it. So you have no reason to get anything below, whatever. Because I think I even tell you which ones you get wrong and which ones you get right. So literally, you should be able to do all of them. The next time I ask you to take a test will be on Monday, then Tuesday. Again, and this time I'm only going to give you 3 choices and 2 choices, that kind of stuff. I'm hoping that this is all stuff we've covered. So here's what I'm going to do is the multiple choice test you take on Friday, I'm going to cover that on Monday. I'm going to go over all the answers. You guys got it? And then the multiple choices you take, or quizzes you take on Tuesday or Monday and Monday and Tuesday next week, I'm going to cover all the answers in class on Wednesday. Yes, I'm thinking that they're all tests you covered in your topics. I tried to keep them stuff that I know that you've either covered before or that we've covered in this past, in Algebra 2. So it's all stuff from Algebra 1 or Algebra 2, and I'm pretty sure I didn't put anything that's on there that is beyond that. That is like rational functions or exponentials or statistics or any of that stuff. Are we cool with that? But today I'm going to finish off chapter 7, polynomial 7, and then that's it. We are done with polynomials, and the next thing we'll be moving on to is rational functions, but that's starting in quarter 3. So in January we're going to start rational functions. You guys got it? I already made your final exam. I honestly think that it's easy. It's way easier than I think it's easier than the midterm that we had, the project one. It's got a lot of multiple choice questions on it. Yeah. I can kind of give you a heads up as to like it really is just like the homework problems. So all the problems that I wrote for the final exam look just like the homework problems that you did. So if you're able to do the homework problems, you should be able to do the stuff. And I think that what I'm going to do is I'll probably add one more problem to it, which includes the stuff that we're going to cover today. Are we cool? All right. So let me get this party started. Sorry, dude. Erasing you, erasing this. All right. Audio check. Can you hear me? All right, cool. Let's do this. So check this out. I don't really feel like the stuff that we're going to be covering in chapter 7 is any brand new stuff. I feel like, all right, maybe it might be brand new stuff. It's not a new equation for sure. Let me know if I'm explaining it to you guys well enough. All right. So check this out. Let's say f of x is equal to x minus 2, x plus 3, x minus 3. Got it? And here's what I want to know. I want to know, when is this thing bigger than or equal to 0? Maybe I should write it over here. Greater than or equal to 0. Yeah, exactly. There we go. Sophia, you're already talking about you're already giving me all of the answers to it, and that's great. So here's what I'm saying. What is the and this is just like what it would be like on the test. What's the degree of this polynomial? It's the third degree. Good. What is the end behavior like? If it's the third degree, I'm thinking it's going to be something like this. Right? What's the leading coefficient of this polynomial? It's 1. Okay, good. And it's positive. That's really what's important. I don't really care what number it is. I just care that it's positive. So I know that it's a cubic function that's probably going to look something like that. What is the what are the zeros of this function? Two, -3, and +3. Perfect. Okay. What is the y-intercept? +18. Awesome. So all the way up here at 18. I would almost venture to say that the graph looks something like that. You guys see that? Okay. But what if we couldn't just straight up graph it? I mean, we using all of our techniques that we've done, we were able to just straight up graph it. And then you ask me, well, when is this thing positive? When is this thing bigger than 0? When is the y value bigger than 0? Well, between -3, 2, union 3, 3 to infinity. Right? But I like what Sophia's doing, because what Sophia's doing is we're developing a very systematic way of approaching how to do these problems. And that's important. Because what we're doing here is we were able to look at this and just graph it and know that this is our answer. This is what our answer should be. But the problem is you won't be able to just straight up graph anything I give you. If I give you some other complicated function, you might not be able to graph it. So there's a way that we need to approach this that is very careful, all right? I'll show you how to do it, all right? Here's what you do. What Sophia's suggesting is you say, all right, I'm going to make a number line. And on that number line, I have 0. 1, 2, 3. 1, 2, 3. Here's 2, and here's 3, and here's -3. And what I'm suggesting is the zeros of this polynomial are very important. They're like what's up, Lucas? All right. Oh, I'm sorry. You're right. You're right. It's the far left. There we go. Okay. The zeros of this polynomial over here are points of interest, POIs, poise. They're points of interest. And so what we're going to do is we're going to plug in some numbers and test out the different quadrants. These points of interest break up my number line into 4 different sections. I have this section over here. I have this section right here. I have one right in the middle, and I have one that goes out all the way that way. Does this make sense to you? So what I'm going to do is I'm going to choose a number, any number. Yeah, this was in the Poly 6 videos. Exactly. I'm going to choose a number that is in this quadrant, in this area, and I'm going to see whether it's positive or negative, whether it's greater than 0, greater than or equal to 0. So let's choose negative 10. Negative 10 works perfectly, all right? And see, the key with this is I don't even care what that number is. I don't even care what the answer is. I just want to know whether it's positive or negative. So here's one thing I do, all right? If I choose negative 10, if you plug negative 10 into here, is this answer going to be positive? Is this parentheses going to be positive or negative? It's going to be negative. Very good. If I plug negative 10 over here, is that going to be positive or negative? Negative 10 plus 3, still negative. If I plug negative 10 into here, would that be positive or negative? Negative. Okay, so I have a negative times a negative times a negative, which gives me a what? It gives me a negative. Very good. So what I'm saying is, in this quadrant, in this section way down here, you have a negative number. Got it? All right, let's test out another number. Let's test out this middle quadrant. Choose a number between negative 3 and 2. And I'll tell you what my favorite number is. It's 0. 0 is a nice number that goes right in between there. Awesome. Okay, so 0 minus 2, is that a negative or positive number? It's negative. Very good. 0 plus 3. Positive. And 0 minus 3. Negative. All right. A negative times a positive times another negative will give me what? It'll give you a positive. Exactly. Very good. So this quadrant right here is all positive. We cool? Now I guess you can try, give me a number between 2 and 3. Give me a number between 2 and 3. 2.5. All right, fine. Now it's weird to plug in 2.5 in here, but if I only care about the signs, it isn't bad at all. I didn't have to do any multiplication whatsoever. I just had to keep tracks of the negative. So if I plug 2.5 here, 2.5 minus 2 is a positive number. You guys got it? 2.5 plus 3 is a positive number still. But 2.5 minus 3 is a negative number. What is a positive times a negative? A negative. Very good. So over here it's negative. You guys got it? All right. Last quadrant. Choose a number that is in our last quadrant. 5. 5 is perfect. 5 minus 2, positive or negative? Positive. 5 plus 3, obviously positive. 5 minus 3, positive or negative? Positive. What is a positive times a positive times a positive? Positive. So this is telling us, when is this thing positive? Well, when you are between negative 3 and 2. You see that? And also between 3 and infinity. Everything else. You guys got that? Look, it's the same answer that we have up here. So this isn't actually that hard to do, and this would also tell us another hint at figuring out how to graph something. By the way, when you're typing something and you want to type in infinity, use INFTY. I always do /INFTY. Anyway, do you guys get this? Is this hard? Is this really hard to do or no? No. Okay, so check this out. There's one other thing that I need to show you, and it's just really a reminder. Remember when we learned about domains? And there were 2 rules that I told you. There are 2 rules I want you to remember about domains. Do you remember what those 2 rules were? Cameron, what I'm saying is, Cameron, what you're saying is it doesn't matter which way we go about it as long as we get the same answer. And you're absolutely right. The thing is, the second way that I showed you is actually the easier way. The first way we did it was when we graphed the thing. And we just graphed it because we're bad to the bone. The problem is we won't be able to graph everything. Does that make sense? So I don't know if I can always get the answer the first way. But if I'm able to do it the second way, that's more systematic. It's easier to test things. You can go about it, you know, boom, boom, boom. All right. Do you guys remember the 2 rules that I had about domains? I want you to write them down if you don't. Okay. Here's one rule. No zeros in denominator. Do you remember where I did that thing where I started ripping up paper and that kind of stuff? Where I said, hey, how many times does this small little zero go into that piece? Yeah. No zeros in the denominator. The denominator cannot have zeros. Got it? Yeah. 1 over 0 doesn't work. Your calculator will say undefined. Your calculator will say, yeah. Yeah, exactly. All right. The second rule, do you guys remember what the second rule about domains are? It's just 2 of them. That's it. No, yes, exactly. That's right, Sophia. No negatives in square root. Okay. I think a better way to put that, maybe a different way to write that, is this. I like this rule, but how's about, this might be longer, but the stuff, this is Mr. Dalday's version of it. The stuff in the square root has to be positive. Or equal to 0. So it can be positive or equal to 0. Cameron, you're right. Imaginary numbers can't go in a square root, but the thing is, we won't have an imaginary number unless we have a negative in the square root. Imaginary numbers are a result of having negatives in the square root. So if we only restrict ourselves to positive numbers in the square root, then imaginary numbers won't even be a topic. Does that make sense? And that's one of our domain rules. So these aren't that complicated. They're not that hard to remember. They're very easy. But let me show you how this applies to our lives. Got it? Let's do this one. All right, here we go. Now this is where this all comes together. Ready? I have f of x equals the square root of 2x minus 1. F of x equals the square root of 2x minus 1. There is a domain issue here. Do you see a fraction? No. But do you see a square root? Yes. Okay. What is the rule about square roots in the domain thing? No negatives in the square root. I'm going to write it like this. Remember how I told it to you? I'm going to say the stuff in the square root. And what is the stuff in the square root? That's the 2x minus 1 has to be bigger than or equal to 0. You guys see how I wrote that? The stuff in the square root has to be bigger than or equal to 0. This is my mathy way of writing what that sentence I wrote down. Okay, this you can solve. This is pretty easy. 2x is bigger than 1. X is bigger than 1/2. Does that make sense? I think that's cool. It was kind of boring. I was confused because some numbers for x will give you positive, and you said you have domain issues. Well, what I'm saying, Lucas, is I'm saying yes, you're right. Apparently, any number that is bigger than 1/2 will give me a positive in my square root. So any number that is bigger than 1/2 is allowed in my house. It's allowed to come inside of my function. But any number smaller than 1/2, you're out. No, get out of here. You are not allowed. Not in my domicile. Does that make sense? So what I'm saying when I say, hey, there's a domain issue, that doesn't mean that every number is not allowed. That just means, hey, there could be a potential for some bad numbers to be in here. If it didn't have that square root, if it was just straight up f of x equals 2x plus 1, or 2x minus 1, there's no domain issue at all. Any x value is allowed in here. But when I put a square root on it, then I said, hey, wait a second, I have to restrict myself to certain numbers. Yes, apparently you're allowed in this function as long as you're a number that is bigger than or equal to 1/2. If I were to write that in interval notation, one way to write that would be 1/2, comma, infinity. Does that make sense? How are we doing with that, Lucas? How are we doing with that, everybody? We cool? All right, let's try this one. J of x is equal to the square root of 1 minus x squared. Got it? All right. Do we have a fraction? No. Do we have a square root? Yes. Absolutely. Square root. What is the rule about that square root? The stuff in the square root, 1 minus x squared, that's what's in the square root, has to be bigger than or equal to 0. Okay, got it. How do you solve this? Well, there's a few ways to solve this. Let's try this. No, I don't want to do that just yet. Let's try this. Because it's going to arise something funky, and I think that it might mess with you guys. Here's what I'm thinking. All right? What I want to do is I want to make that number line. I want to find the points of interest, and then I want to set quadrants and test them out. That's what I'm going to do. Got it? It's not really that hard to do, but to find the points of interest, I say 1 minus x squared equals 0. Because my points of interest are when it equals to 0. Got it? All right. So what is that answer? 1 equals x squared. Take the square root of both sides. When I take the square root of both sides, what do I need to remember to add? Do you remember? The plus or the minus, very good. Plus or minus, 1 equals x. So apparently my points of interest is at 1 and negative 1. Got it? Okay. Let's test out some quadrants. Let's test out this first quadrant over here. Choose a number that is in quadrant, the first one. Why isn't the plus or minus square root? Oh, I only put the plus or minus on one side. Okay, here's my answer to that. What Sophia's asking is, if I had x squared equals to 1, which is what I had here, and I want to take the square root of both sides, When I take the square root of that, that just becomes x. This becomes the plus or minus square root of 1. Lucas, I think your answer is kind of correct. I like your question, Sophia. I think what Sophia's asking is, why don't I put a plus or minus on this side as well? Is that what you're saying? All right, let's try that. So basically, here's what my answer is. If you put a plus or minus on both sides, that would be equivalent of not putting a plus or minus at all. Let me show you. If I consider the plus case, x equals square root of 1, which is x equals 1. If I consider the minus case, and I can put negative on both sides, I have negative x equals negative the square root of 1, which is x equals 1. It's almost like you didn't do anything with the plus or minus. You kind of canceled out that plus or minus trick by putting it on both sides. That's what I'm saying. So only put it on one side. All right. But we have our points of interest. We have our quadrants. Let's choose a number that's in this quadrant. Sophia, actually, I think Lucas was absolutely right. If you put the plus or minus over here or over here, it doesn't really matter. I think traditionally we put it on the number, not the variable. Because we want to solve for the variable, so we don't want a plus or minus in front of it. We want to solve for the positive variable. So, that's why we do it. Okay, let's choose a number that's in this quadrant. Let's say negative 10. If I plug negative 10 into here, this would be x minus, what is negative 10 squared? A 100. So what is 1 minus 100? Positive, or negative 99. There we go. So it's a negative number in this quadrant. Does that make sense? Okay. What is the number in the second quadrant that we're interested in? Between negative 1 and 1. 0. It's a perfect number. All right. 1 minus, what is 0 squared? 0 squared is 0. So 1 minus 0 is 1. So it's a positive number over here. So in this region right here, that's all positive numbers. Does that make sense? Okay. What about in this region over here? Let's choose a number that's way out here. Like, let's say 10. As long as it's bigger than 1, we can choose it. Or let's do 2. Let's do 2. 2 is, right here. Let's see what happens there. 1 minus 2 squared. That would be 1 minus 4, which is negative 3. A negative. So, where is my domain? When is this thing actually bigger than or equal to 0? Well, between negative 1 and 1. That is my answer. Does that make sense? Are we cool with that? Now, Cameron, I'm gonna go off of something that you said. Where, all right, so you understand how to do this one, Cameron, right? Now, believe it or not, this one was actually easy enough for us to graph in our head. We can actually do that first method that I showed you. I'm going to rewrite this to make it look like this. Negative 1x squared plus 1. We know how to graph this because it's a parabola. And it's an easy version of a parabola. This parabola is being moved up or down. It's a regular parabola that is moved up or down. It's moved up. By how much? By 1. Okay. And what about the a value of this polynomial, of this quadratic? What is that telling me? It's negative 1, so what is it telling me to do? It's a sad face parabola. So really, if I were to graph this parabola, it would be a sad face parabola that is moved up to 1, right? And we know that this thing crosses 0 at 1 and negative 1. Do you see how this thing relates directly to this? See this right here, negative 1 and 1, that's the interval when this graph is positive. And then over here on this side of negative 1, that's when the graph is negative. And over here on that side of negative or positive 1, that's when the graph is negative as well. So what I'm saying here is you could use this route or this route. I could use this route. In fact, honestly, I would probably have chosen this route because because this particular graph is easy. The problem is I'm not able to just graph everything I can in my head. So what I like doing is doing this very systematic approach of doing number line, points of interest, and test points. We cool? But you get the same answer. Apparently the answer is negative 1 and 1. So what I'm saying is, here's my house, but you are not allowed in it if you are a number that is not, you are only allowed in it if you are between negative 1 and positive 1. We cool? All right. I'm going to try another one. You guys ready? This one I'm going to write down and we'll talk about it real quick. This one is actually really easy. Ready? K of x is equal to the square root x minus 2, x plus 3, x minus 3. All right. What is the domain of k? What are the allowed values that x is allowed to be of k? Well, the rule goes, you take whatever's inside, you set it, you say x minus 2, x plus 3, x minus 3 is bigger than or equal to 0, right? We just take that thing, bigger than or equal to 0. Got it? Now, we already solved this. We already know how to do this. I'll tell you what the answer is. I think the answer was between negative 3 and 2, union 3 to infinity. Right? If you don't remember, just go rewind back to the beginning of the archive. That's the first thing we did. So what is the domain of k? The domain of k is this. That's the answer. Done. We're done. You guys got it? All right. Let's try another one. These are fun. I think they're not bad. Here's a good one. I like this one. Ready? R of x is equal to the square root of x cubed minus 6x squared plus 11x minus 6. Oh, snap. And they tell you, note that r of 1 equals to 0. Doesn't the square root change it? Oh, okay. Oh, okay, Cameron, you figured it out. All right. How do you do this one? This one looks tough. It is tough. It's tough. Okay, here's what you do. We want to find the points of interest of this thing right here. We basically are saying x cubed minus 6x squared plus 11x minus 6 has to be bigger than or equal to 0. I want to find the points of interest. This problem might be long. I'm going to go through it. I'll probably go through it quickly. I want to find the points of interest, so what I do is I set this equal to 0. The hard part is I don't necessarily know how to factor this. There is no quadratic equation that factors this thing very nicely at all. If it were this, then the quadratic equation would be perfect. But there is nothing there. We're stuck. But they did give us an out. They told us that r of 1 equals to 0. What is that saying? It's saying that if you plug in x equals 1, the y equals 0. There we go. That when x equals 1, y equals 0. That's telling us one of the zeros of our polynomial. We have a polynomial, and apparently one of the zeros is at x equals to 1. Does that make sense? That's like saying if I were to factor this thing, then I know that one of this would be x plus 1. No, I'm sorry. X minus 1. Good, exactly, Lucas. So here's the thing. We want to figure out what the second half of this thing is. So what we should probably do is use polynomial long division. So x minus 1, I'm just going to do it right here if that's all right with you. I'm going to do it quick. What times x gives me x cubed? X squared. This goes x cubed. This goes negative 1x squared. Subtract this down like negative 5x squared. And this kills that. Am I doing it right? Yes. Okay, good. Drop down to 11x. I just have to do it kind of carefully. You got to go through it slowly. What times x gives me 11x? Or no, what times x gives me 5x squared? That's what I want to know. I need a 5 and an x. Actually, I need a negative 5x because I want negative 5x squared. Okay. So this becomes negative 5x squared plus 5x. Yeah? All right. Now change the sign on that thing and straight up add them. That becomes 6x. Drop this thing down. That's a negative 6. What times x will give me 6x? That's simply just 6. And then we go with 6x minus 6. Change the sign, add them up. That's 0. We're good. That the teacher didn't give this all in the final. What is that? From what my sister told me, it was so hard, this thing. Oh, you're talking about polynomial long division is really hard? You're saying this is really hard? Yeah, no, it's not. I don't know. What do you guys think? Is it hard? I don't think it's hard at all. I mean, it's a lot of writing. It looks ugly as heck. If I saw it, I'd be intimidated. I'll promise you that. But it's really, what it is it's bookkeeping. You're just keeping track of things. That's all you're doing. And it's no harder than multiplication and subtraction. That's literally all you're doing. Multiplication, subtraction. Multiplication, subtraction. You just got to be careful. That's what makes it hard. But it's not really that hard. Anyway, is it all right if I erase this bottom part? You guys can take a picture of the screen. Can I just erase this little bottom half right here? All right. So what I'm venturing to say is this. This thing right here becomes x minus 1 times x squared minus 5x plus 6. Are we cool with that? All right. Equals 0, of course. Okay? And if I were to FOIL this all together, I bet you I would get this. All right. Can I factor this? Let me see if I can factor this. This right here. Hopefully I can. I know a way I can guaranteed get it. I can promise you I know a way that does it. Would you guys like to know? What will guaranteed factor that? Guarans will barons, it will work? What's your thoughts? Yes, exactly, the quadratic formula. Let's not try to pull out that bazooka just yet. Let's see if we can factor it. Let's see, you got an x and an x. What are factors of 6 that will add up to 5? I'm thinking 2 and 3. So a negative 2 and a negative 3. Are we cool? Awesome. This right here is this thing right here factored down. If you don't believe me, FOIL it all out, and you should get the same thing. These are our points of interest. Got it? These are our points of interest. So if we draw our number line, our points of interest is 1, 2, and 3. Now all we got to do is choose points, choose quadrants, choose numbers that are in the quadrants that we're interested in. So I'm going to choose a number between that's lower than 1. 0. Okay. Now, which one do I plug it into? Do I plug it into here, or do I plug it into here? I'm going to choose 0 as my x. Do I plug it into here or into here? I like what Sophia says. She said the factored one is easier, which implies that it doesn't matter. It really doesn't. You can plug it into here or here because these are the same thing. They are mathematically equivalent. The thing about the factored one, yeah, they're the same equation. The thing about the factored one is it just ends up being a lot easier to do. So plug it into here if you ever have a choice. Well, Cameron, what I'm saying is the square root is still there. But what I'm trying to figure out is when is this thing inside the square root bigger than or equal to 0? So I got rid of the square root. And by the way, this long division sign is not a square root. It's something different. But I got rid of the square root by just saying everything inside the square root, I want to set it bigger than or equal to 0. The square root is still inside of my original equation. I'm kind of ignoring it right now because I'm saying, well, whatever it is inside of that square root has to be bigger than or equal to 0. Does that make sense? Well, Sophia, the reason why I just said straight up equal to 0 is because I want to figure out what my points of interest are. Does that make sense? I temporarily erased that and pressed equal. I put equal to 0 because when I set things equal to 0, that's when I figure out what my points of interest are. That's how I got the 1, 2, and 3. But now we're testing the quadrants, and what that does is it kind of turns that back into a greater than or equal to sign. I didn't have enough room on the whiteboard to write all this stuff up, so I started erasing bits here and there and going back and forth. And maybe that might be confusing you, but I'm glad we're clarifying all of this stuff. Does this make sense to you, though? I think it's really interesting. It makes me feel really bad to the bone that I'm able to do this stuff without a calculator. All right, anyway, let's plug in 0, okay? If we plug in 0 into here, 0 minus 1 is negative. 0 minus 2 is negative. 0 minus 3 is negative. If I have a negative times a negative times a negative, what will I get? I will get a negative number. So this is a negative quadrant right here. Okay? Let's choose a number between 1 and 2. Let's choose a number between 1 and 2. 1.5. Okay. So 1.5 minus 1. Is that a positive or a negative number? It's positive. Very good. 1.5 minus 2. Is that positive or negative? Negative. 1.5 minus 3. Well, obviously negative. So what is a positive times a negative times a negative? A positive. Very good. So in this quadrant between 1 and 2, this thing's positive. In fact, I'll tell you what. We could go through and keep doing this. Just keep going through this. But I'm going to tell you what I know for a fact. This is a negative quadrant and this is a positive quadrant. Would you like to know how I know this? We've actually done this before. because it's a cubic function. It crosses at 1, 2, and 3. So it must look something like this. Also, here's another trick. Whenever it goes to a 0, or whenever it goes to this kind of 0, it goes right on through, right? So it changes from a negative to a positive. And then over here, we're going from a positive to a negative. And then over here, we go from a negative to a positive. That's what kind of happens. Does that make sense? So, this is my answer. My answer is between 1 and 2 and 3 to infinity. This is my answer that I would put in. 1 and 2 and 3 to infinity. We cool? So what is the domain of this? You're allowed to come into this function as long as you're an x that is between the numbers 1 and 2, or if you're bigger than 3. If you're anything besides that, get out. You are not allowed here. We cool? What I like about these problems is I honestly feel like they're not hard. They really aren't. They're not hard. They're just, well, they're long. And the reason why they're long is because they take a technique that we learned here and a technique that we learned there and here and there and puts it all together. And no, there are not a lot of rules to remember. There's just actually 2 rules to remember for domains. No negatives in the square root, no zeros in the denominator. We cool? Okay. There is one small thing I want to talk about real quick, and I'm going to change the problem up just a little bit. So that problem is done. I want to change something up real quick. Here's what I want to tell you. Watch this. What if I did this right here? So it's a different problem completely. I'm going to erase the top. But what if I did that? Does that make sense? Okay. Well, what happens is, no, it's not a quadratic. It won't become a quadratic. It will actually become a 4th degree polynomial. Yeah, you're right. But what happens is, let's test out one area. Let's test out one quadrant. If I plug in 0, this will be negative, right? If I plug in 0 here, that will be negative here. And if I plug in 0 here, that would be negative 3, correct? But it's negative 3 squared, so it's a positive. Got it? Does that make sense? So apparently this region over here is positive. I want to show you folks. Okay, wait, I'm waiting. Are you saying this, Sophia? Is this what you want me to write down instead? Okay, all right, yeah. It's going to do the same thing. It will do exactly the same thing. Our points of interest is still 1, 2, and 3. And 3, right? The zeros of our thing is 1, 2, 3, and 3. We cool? All right. And so a point of or so the region I want to test out is some number on this side of the 1. So I'm going to choose 0. I plug in 0 here. That's a negative times a negative times a negative times a negative. Negative, 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 negative. 4 negatives make a positive. Very good. So it's positive. Watch this. This is cool. How did I do that so quick? This is kind of drawing on something that I taught to you guys a little bit earlier. There we go. This particular 0 right here is a normal kind of 0, right? So what it does is it just crosses the y-axis, or the x-axis. That's what it does, is it crosses the x-axis. So it goes from a positive to a negative. It just switches the sign. This 0 right here is also a normal kind of 0. So when it crosses that 0, it goes from a negative to a positive. It switches the sign. But this 0 right here is a 0 of multiplicity 2. Did you guys hear that? A 0 of multiplicity 2. What it does is it kind of 1, 2, 3. When it comes here, it crosses the here. It crosses here. But what happened is, yes, multiplicity. It has 2. You know, your factors are, your zeros are 1, 2, 3, and 3. I said 3 twice. So it's of multiplicity 2. What happens at that 0 right there is it kind of comes down and kisses it. This is the way that your 4th degree polynomial can have 3 zeros. Remember I asked you, can a 4th degree polynomial have, it can have 4 zeros, yeah, but can it have 3 zeros? There we go. Yes, in this kind of like localized region, and what I mean by localized is like zoomed in region, it will kind of look like a parabola in that area because it has an x squared kind of deal going on. Are we cool? So this is advanced, and I don't expect you guys to know how to do this right off the top. I just really want to show you, but if I know one of them, and I know the type of zeros they are, if they're a regular kind of 0 or if they're a parabolic 0, then I can immediately get the rest of those things. And maybe the reason why I'm showing you is because, yes, I still want you to test each region, but at least when you look at this, you'd be like, oh, okay, that makes perfect sense. Right? Because if you were to test these regions, you'd look at this and be like, what the heck is going on here? But then you think about it and it's like, oh, I see. It's just kissing the 0 at 3. It's just kind of going, whoop, and then touching and going. It's not going all the way through. It's just kind of going right there. Kiss and off. We're cool? So does the domain include the x-intercept values? Okay. For this problem, it does include it. Because the reason being is because when we have a square root problem, we said it's greater than or equal to 0. So at those values of, like at the 1 and the 2 and the 3 to infinity, it included the 1 and 2 and also the 3. So I'll put brackets here. It's inclusive because it's greater than or equal to 0. If I strictly said greater than, then I would use parentheses only. Does that make sense? Now, I'll be honest with you, I've only covered one rule. And for some reason, I covered the second rule. So I'm going to make up a few problems. I'm going to show you how to cover the first rule. Because remember, there's two rules with domain. The second rule was there's no square roots in the denominator. What was the first rule again? No zeros in the denominator. Yes, no zeros in the denominator. Okay. So what if I had this? 1 over x cubed minus 6x squared plus 11x minus 6. All right. Is there a domain issue? Okay. I'll rewrite this a little bit. And I specifically chose this one because we already did this problem. I think it was this. Right? This thing is the same as that. And I don't need to go through all this stuff all over again, right? How did I get from here to here? Well, I took the note that they said 1 was one of the factors, and then I used long division to get the other two. It's the same steps. But then all you do is this. This is all you do. It's very easy. Actually, this rule right here, when we're talking about no zeros in the denominator, is way easier than the square root rule. It's easier. I saved the easier one for last. I'll show you how to do it. You ready? You set it not equal to 0. You say the stuff in the denominator not equal to 0. So it's an equal sign with a slash in there. Mathematically, we can treat this not equal sign just like it were an equal sign. So how do we solve this? Oh, okay. Well, back when it was an equal sign, that was easy to solve. That was telling me, oh, x equals 1, 2, or 3. But now, when it's a not equal sign, all I need to say is, okay, well, x cannot equal 1, or x cannot equal 2, or x cannot equal 3. That's it. That's it. I kid you not. X can equal anything as long as it's not 1, 2, or 3. It can be 0. 0 is perfectly fine. It can't equal 1, it can't equal 2, or 3. Lucas is saying, well, why can't it be 0? Okay, fine, Lucas. If you plug 0 into here, you have 0 minus 0 plus 0 minus 6. What you have is 1 over negative 6. There's no domain problem there. Negative 1, 6 is a perfectly good answer. You get it? So 0 is allowed. The only numbers that aren't allowed is 1, 2, and 3. Okay. How would you write this in interval notation? That is a little tricky. I'll show you how to do it. It's actually, it's not hard. Negative infinity to 1, but not including 1, and 1 to 2, but not including 2, and 2 to 3, but not including 3, and 3 to infinity. Because if you think about it, the number line would look like this, right? It would be 0, 1, 2, 3, It would have an open dot here, open dot here, open dot here, but everywhere else would be filled in. So if you wanted to write that in interval notation, it would be tedious and kind of a pain, but that's exactly it. You would go from negative infinity to 1, jump over 1, go from 1 to 2, jump over 2, go from 2 to 3, jump over 3, go 3 to infinity. Honestly, I'd probably ask you to tell me your answer like that. I would say something like, what is a value that x is not allowed to be? Then you would just put in 1, 2, or 3. That's it. Are we cool with that? Here, let me give you another one. I'm going to erase this. Is that right? All right. What is x not allowed to be? What is the domain of this? X is not allowed to be 2, negative 3, or positive 3. It can be anything else, as long as it's not 2, negative 3, or positive 3. That's it. There we go. Yeah, that's right. Yeah, these are way easier because all you do is you circle the denominator and you say that cannot equal to 0, and then you basically solve for x with a not equal sign instead of an equal sign. But all the math of doing things with a not equal sign is exactly the same as if it were an equal sign, so it's nothing new. You're just making sure to put a slash inside of your equal sign instead. That's it. That literally is it. That's domain. So honestly, chapter 7 isn't hard. Domain is not, the domain questions aren't that bad at all. But what I like about them is they take a piece from here, and they take a piece from here, and here, and here, and here, and here, and here, and kind of put it all together. Yeah, I would agree. I would not disagree with you to say that they're a little annoying. They'll take work. But they're pretty straightforward. I guess my last question is, what if I did this? What if I did this to you? Okay? Do you see what I did? No, you can totally have a square root in the denominator. That's perfectly allowed. Right, right. Cameron's thinking, oh, crud. Okay. Here's how you do it. It's actually easy. You want to see something? It's crazy. It's crazy how easy this is. Okay, we did this problem already, twice, right? We already discovered that x cannot equal 2, x cannot equal negative 3, and x cannot be positive 3. Anyone disagreeing with me? Because if x were 2, 3, or negative 3, it would cause the denominator to be 0. Okay? We also discovered that x is between negative 3 and 2, or 3 to infinity. Right? Because of the square root, right? We did that problem separately as well. And we know that. to be the case. Okay? So notice how I put an equal to sign over here. Or I didn't put an equal to sign, I put brackets instead of parentheses because that's including. And Sophia, you already asked me that question. This came from when we were talking about the square root and we put it greater than or equal to, right? But here's the thing, is when we combine these two pieces of information, all that it is this. Right? Because this says it's between -3 and 2, including -3 and including 2. And this says it's bigger than 3, including 3. But this says don't include 2, -3, or +3. So all I did was I changed them to parentheses, and that's my answer. It's literally doing 2 of these problems. It's not hard. It looks hard. And it's not even doing 2 of these problems, because once you find the zeros, or once you find this information right here, this one is super easy to get, because this is just doing the zeros. I don't know how to make that any easier. Anyway, it's a good question. But that's it. That's it. If I wanted to really mess with you, I would probably give you something like that. Hint, hint. Just letting you know. That is a bad way. Or that is way bad to the bone. Oh, yeah, it is bad to the bone. Absolutely. But I'm just letting you know. If I wanted to really give you a tough time, that is tough, and maybe test you on something, I would probably give you something similar to this. That is, of course, if I was testing you on something. I can't tell you what's on the test. But I'll tell you this. I honestly feel like you will be pleased with the test. Sound fair? I honestly feel that if you kept up with your homework, you are going to find this test to be, dare I say, easy. The test includes mostly stuff on polynomials and functions. But there are a few in there that I've thrown in that were straight up from quadratics and lines. Got it? All right. That's it. That literally is it. Linear functions will be there. You might want to brush up on how to find like the slope of a line. You might want to brush up on how to find like what else? The y-intercept. All I'm saying, I'm talking about what's probably on the test. What's on the test. I already wrote it out. It's there's polynomials and functions, which is quarter 2 stuff. There are maybe a third of it is lines and quadratics, but 2/3 of it is polynomials and functions, right? For lines, you'll want to remember how to do the y equals mx plus b, and the definition of slope, and that kind of stuff. Can you start the standardized test now? The answer is yes. In fact, I'm going to send out an email to say, make sure you do them. On Monday, I'm going to go over all the answers that on the test that's this Friday. So next week, Monday, I'm going to go over all the answers. So obviously, I won't take any late homework on those standardized tests because I'm going to give you all the answers. You guys got it? So you can't take it late. So, and you have, I mean, it's a 15 question multiple choice test that has options A, B, C, and D, 4 options, and 4 tries. How could you get it wrong? And I tell you which ones you got wrong and which ones you got right. And then the second time I do it, I'm going to give you only 3 tries. And then the last time I give it, I'm going to give only 2 tries, I think. I'm done. I'm done. We've covered all of polynomials. I think that all of polynomials has been talked about. Let me see who else we have here. We got kind of a small class. Here's my question to you is, no, we have a huge class. I don't know where everybody is. Like, what's the deal? Here's my question is, at this point, I got like 15 minutes before I got to start up my next class. I've covered all of polynomials. I thought that this one was the most interesting. I really enjoyed it. Is there anything that you guys need me to recover? I think someone was asking me about Poly 5, but I'm not sure if they're here. Well, what I'm asking is there anybody who has any last questions? Yeah. Was quarter 2 easier than quarter 1? Huh. I think quarter 3 is going to be as easy as quarter 2. Quarter 1 was a lot of quadratic equation, moving around quadratic or parabolas. I think quarter 3 is going to be easy as quarter 1, as quarter 2, as long as you remember how to factor. We're going to go back to doing a lot of factoring, which isn't hard. It really isn't. And I think we might even be doing some like techniques of long division. Which also isn't hard. I mean, sorry, Lucas, your sister was wrong. Long division isn't hard. I could see how a teacher could make it hard. But I honestly think that it's not that bad. Okay. All right, anyway, class is finished. I'm going to finish 15 minutes early. I had fun. I hope you did. No one has any other questions for me?